Next question number 3C. A rectangular ABCD 8 cm, 3 cm, and the distance from the straight wire current 22 ampere. The distance 0.5 and the current flow in the wire is 22 ampere. First question, calculate the magnitude flood density on the loop segment AD and BC. So what is the magnetic flood density at the wire from length wire AD and BC? So as you know, if the current flow in the wire, so the current produces the magnetic field. So this is magnetic field produced by the current, and direction, if you use the right hand, so direction is the like this, and this is a out page, and the spark is a into the page. So if you look at the AD, so the magnetic field here is into the page, and the same process, the magnitude at the BC is also into the page. Number one is what is the magnitude B at AD? So as you know, magnitude or density or magnitude B, magnetic field B at AD, you can use this is magnitude at AD is an equation mu naught I divided by 2 pi r. So mu naught is constant, 4 pi exponent minus 7, right? So I is a current flow, is a 22 ampere, and R is a distance between AD to the wire 0.5 cm, but convert to the meter is minus 2. So you can find the BAD is equal to 8.8 exponent minus 4 Tesla, right? This is for the B density B magnetic field at AD. And at the BC, the same process, B at BC, B here is also the B here into the page, right? Out page into the page. So equation mu naught I divided by 2 pi r. So the value of the mu naught, yes, constant, 4 pi exponent minus 7, and the I is 22 ampere, and the R distance here is from BC to the wire here is 0.5 plus 8.0, so meaning 8.5 convert to the meter is minus 2. So now you can find the BC, B magnetic field at BC is equal to, if you use the calculator, the value here is 5.2 exponent minus 4. This is 5.2 Tesla. This is unit Tesla, right? And next question is, what is the magnetic force on the loop segment AD and BC? First question asks you to calculate the magnetic flood at AD and BC. Now, what is the magnetic force on the loop segment AD and BC? So the first you start from the force equation. Force X on the loop is given by the equation mu naught I1 I2 times length wire divided by 2 pi r. Now you have this is a straight wire, current flow 22 ampere, and the first segment AD, meaning the force, magnetic force on the loop segment AD, the force at AD here is a mu naught constant. This is mu naught constant, 4 exponent minus 7, and I1 is referred to the current flow to the first wire, 22 ampere. This is 22 ampere, and the I2 is referred to the wire current flow in the wire segment AD. So now this is here is a 1.5 ampere. So the current I2 is 1.5. So the length AD here is a 3 3 centimeter. We need to convert to the meter is a 3 exponent minus 2. So the 2 pi and the r here is the distance between the two wire is a 0.5. 0.5 centimeter convert to the meter is minus 2. So you can find the force. This is for AD. So the force for the AD is equal to 3.96 exponent minus 5 Newton. And direction. So what is direction? Yeah, direction. How you can find the direction? So now you can find the force. Force on the AD here is a 3.96 exponent minus 5. So to find the value, to find the direction, first you consider the magnetic field produced by wire 22 ampere here. Straight wire here is a, this is outward, and now at the this part is a into the page, into the page, into the page, into the page. So meaning you can use a right hand, sorry, left hand. Your finger is direction of the force, first finger is direction of the B, and the second finger is direction of your I current. So this is direction of the I, direction of the I to upwards, and direction of the B to into the page. So use the left hand. So direction of the force is to the left, right? So same process for the BC. What is the direction? Sorry, before we find the direction, force X on the BC, yeah, still use the same equation. Mu naught I for the straight wire. This is, let's say, I1, and the I2 is the I flow in the wire BC or segment BC here, BC, and times the length is a 3 centimeter convert to the meter, and 2 pi, and the distance between segment BC to wire here is a 8 cm plus 0.5. So this is for R. So you can find the value of the BC. So FBC, you can use your own calculation. I just give you the final answer. FBC is equal to 2.33 exponent minus 6 Newton. But the direction, yeah, still you can use a left hand. So direction of the B also into the page here. This is B produced by wire, straight wire, 22 ampere. So into the page. That's why the part here we have a B into the page. So the direction of the I is downward, right? So if you use your right hand, the force direction of the force is to the right, right? So this is I, this is B into the page, right? And use the left hand. So direction of the force is to the right, right? Thank you. Hello.